Hello, everybody, and welcome to episode 19 of the Hot Path Show. I'm Johnny Turbo, joined in by Tobias. Welcome in, Tobias. How's it going today?
It's going great. It's going great. How about yourself?
I am just fantastic. Excited to be here once again. Unfortunately, we're not live today on the Hot Path Show as we typically are on our Friday
Are
afternoon.
you sure?
Oh,
Aren't we? No, I'm just kidding. Continue. Sorry.
should probably make some fun graphic or something pop up to be like, whoa, I don't know. But yeah, so once again, there was just kind of some. I'm going to be out traveling on this coming Friday, so got to pre-record because the show must go on. So hopefully, we'll be back next week with a proper live episode of the Hot Path Show. And yeah, depending on scheduling and stuff, hopefully I'll at least be able to be there in the chat when this goes live, like I was doing last week. By the way, Tobias, I don't know if you caught last week's show episode at all, but it was a really good one. Danny and I talked about creating source generators in Unity.
Yes, I watched a bunch of it. Not all of it, but mostly. I have a bunch of things, but we can. I don't know. We can take that when it fits.
Yeah, no. I was just saying it was a great episode. I learned a ton of things, and I started messing around with a little bit of Rosalind source generators on my own. So it was a very good episode. I know a lot of other people like that one, so do go check that out if you haven't seen it already. And I do think it also is going to be kind of like a good fundamental video for some like the things that we want to do in the future. I know Danny has some cool ideas about some things that he wants to create that kind of like uses source generators. So just kind of, yeah, having that fundamental knowledge of what they are, how you set them up in Unity is just kind of good fundamental knowledge. But yeah, did you have any kind of thoughts on what you had seen of the show and kind of some source generator stuff? Because I know you have used some source generators, but it was just kind of like your own custom template type thing, right?
So I think there's like a big difference here between what he talked about, and I need to actually. I haven't talked to Danny about this, but I need to talk to him properly because, like, if I understand it correctly, this was like not necessarily to like generate. It's partly to like put in new stuff into the already existing code or make like a mirror image of code and like modify it to make additional things like Danny's job around
Yeah. I was just
generating
gonna say,
the
yeah.
verbose stuff around around dots. Like when I talked about a few weeks ago the source generator or the source code generator as I call it for my network engine. That's just simply string manipulation. It just spits out a long string and then just compiles that as a CS file. That's I mean, practically it ends up in a very similar way where you write a small amount of things declarative. You like, oh, this is what I want to do, and then it spits out
Right.
something that does a much more complex stuff. But like whatever, like it's two different worlds of like how to do it. I didn't know. I
Yeah.
haven't watched. I worked with the Roslyn analyzer, but not the
Okay.
generation. Continue. What did
No,
you
I was
say?
just gonna say, yeah, it was really cool how you could do a lot of like complex kind of analysis on your source code. Like really digging into what all the different types of all the syntax tree nodes and everything like that. But it did seem like there actually were two types of generators, where there's kind of like the incremental generators, which are like things where you can kind of like maybe add an attribute to something and it can kind of like extend the behavior of that class or whatever. I'm blanking on the name of like kind of what the original one, but it was like more just kind of like traditional code generator, kind of like something more similar to what you have, where at least in the example that Writer provides, you kind of have like an input text file, and then just like based off of each kind of line of that text file, it will generate a class with that name.
Yeah.
And then, yeah, of course, you can go a lot deeper and everything with
Yeah,
that.
I think there's like the first thing which was a very big clue to me, like how different this was that even though you brought up the partial keyword and you like Danny like nodded and like the partial keyword like is used, but it wasn't like a big concern to him because the way it was framed, the way his solution was framed, meant it wasn't. Yeah, I don't know. It seems like he spits out a piece of code that is almost like hidden from view, and you like you need to in Unity you need to specify a preprocessor defined to actually get it so you can debug it, and then you have to map it back to whatever line of code if you want to debug it and all sorts of things. My version of it is I just spit out
Yeah, just code that you want to use in your
yeah,
project, right? Yeah.
straight up. And
Yeah.
I happen to have that folder ignored in Git, so I don't have to care about that in my project.
Right.
And that's one way to deal with it. But like, yeah, the whole like sort of lifetime and logistics around the code actually generated seem to be completely different from how I did it.
Right.
And
Right.
I remember
Yeah, totally.
I talked to Frederick or Zek, one of the programmers on V-Rising, when he was the one who tipped me off about partial from the beginning. He was like, make sure to use partial because otherwise code generation is a nightmare. And he said like, well, we made this whole thing where you save or you do something and it automatically rebuilds everything in the background and shoves it completely in, but that has some problematic. If you're just alone or you're just a small team, then you should just have like a menu drop down and it just generates a file and puts into your asset folder and just compiles with that. So I think this is a case where sometimes you don't need a Ferrari to go to the grocery store, and maybe I chose this bicycle that I just needed here, and maybe I slightly rebuilt a lot of stuff from scratch that probably already existed, but it's hard. It's sunken cost fallacy. Goes both ways sometimes you just do it yourself, or it's hard to know exactly what's the more efficient ways. But I was very surprised.
I think your solution's good. It works well for you and everything. And
yeah. But for me, it was fascinating to like, oh wow, this is just completely different from what I thought it would be.
It goes deep, right? Yeah.
Yeah, and I think also like the guys over at Stunlock with V-Rising who made source generated networking code would maybe not at this point, but at one point in time in the early days of the V-Rising, they would probably look at what Danny presented and be like me, like, oh, that's a different. I mean, we know what Roslyn is and how syntax trees and all the token systems and everything like that. I worked with that part. But I've never like generated anything like that and used Roslyn in that way. So that was very fascinating to me.
Yeah, absolutely. So yeah, once again, go check out episode 18 of the Hot Path Show for a good introduction into using Roslyn source generators in Unity. Before we get into some other kind of topics of discussion here, do just want to point out that the Unity Asset Store is hosting another sale right now. This is called the Template Toolkit sale. So there's a lot of kind of like template type assets that can kind of like give you like a good solid kind of base of things to start off with. So there's definitely a lot of good things in here. I just saw the sale like right before we went live, so I haven't had like a good chance to go through like everything in depth to see what everything is going on. But I did see, well, I have it just kind of bookmarked on this other tab here. There's this Dots Traffic City assets, which is a new Dots asset that recently came out. The developer actually reached out to me after he published it and gave me a key for this asset. So I do have it. I haven't, unfortunately, gotten any time to play around with it, but I'm hoping that by the time this sale ends, I can do like kind of a proper review on this asset. But yeah, I mean, again, you can kind of see it gives you the, a lot of kind of the, people moving around and cars moving around, just kind of like, how a crowded city type works. And you can see there's kind of some animations built in and everything like that. So does seem like a cool asset. And if you're trying to build something that has some type of city, maybe it's again a good kind of base to build off of, and you can kind of go from there. So do think it is pretty cool. It is available again for 50% off as part of this sale. And yeah, regardless, I do want to play around with this asset a little bit more. So yeah, check out that sale if you're interested. Then also do want to mention that you can support us over on Patreon as well as through YouTube memberships, where we do have some bonuses available for you. So I've finished basically moving over all of the Patreon exclusive bonuses over to YouTube memberships. So if you're at the whatever tier of YouTube membership, you will have all the previous bonus content from the beginning of this, when we started this show, up until now, and then also by the time that this is airing, we'll have the bonus content for the month of May up. So I do have a bonus video up. That's just kind of me talking about why you should specialize in something in game development. Not necessarily dots, but of course I'm going to be talking about my experience with specializing in dots, but also kind of why you should generalize. So specialization is great, but it's not really everything. You kind of really do need to have kind of like a wide breadth. So I kind of go into detail in that in the bonus video there. The behind the scenes video for the people at the L1 cash support level and up. I've actually just did like a behind the scenes video of like how I made that video, that bonus video that I just talked about, just kind of going through my process of, creating the video and everything. So it's a little bit of a meta on there. And then do also have the kind of monthly Q&A episode. Didn't get any questions submitted for this one, so if you are at the L2 cash level or up, make sure you stay tuned for those Q&A posts where you can basically ask me anything you want. But in lieu of that, I'm putting up a video. I'm just kind of talking about some ideas of some things that I have kind of for the channel and some cool upcoming ideas that I have coming up. So, if you are at that level, you can get a little bit of insight into, those kind of things that I have coming up. So, definitely, a lot of exciting stuff. I do also want to mention this thing came out here today, that the Game Maker's Toolkit Game Jam was just announced. So this is happening in August 16th to the 20th. Let me refresh the page here. So this was just released maybe, 6 or 7 hours ago, and there's already 7,000 people that said they wanted to join the GMTK Jam. So that's insane. So the GMTK Jam is a cool one. It's kind of like very design focused. I've had fun participating. I did it once in the past, and hopefully I'll kind of have some time for this one here. And then also I do want to mention that Turbo Makes Games, we are going to be hosting a game jam this summer. Probably end up being before the GMTK game jam. I think next week I'll have kind of some more details on what the date and kind of the general rule set of things are going to be. But so definitely if you are interested in game jams, we got the GMTK game jam in August, and then the Turbo Makes Games Dots game jam. That's probably going to be like early July is kind of when I'm thinking of that. But again, I'll have more details on that for y'all next week. So I guess those are kind of our miscellaneous announcements. So we can get into some of our topics of discussion here. So we'll go ahead and start with the Prefetch, just our little kind of warm-up topic. And I'm going to ask you the same thing that I asked Danny last week, because when I asked this to Danny, because the reason that I asked him it is because he basically recommended me a book. And so I just kind of wanted to ask him, what were some of his favorite books and everything like that. And he's like, well, I don't actually read. Like, that's kind of like the only book that I read. He ended up coming up with a couple other options later on. But wanted to ask the same question to you. Are you a big reader at all? Do you have any good books? Not even necessarily programming related, but just kind of in general, good books that you enjoyed or might recommend?
Yeah, I used to read a lot, and well, I usually read a lot. It's been a little bit of a pause for the past maybe year or so, but I barely read programming books at all, actually. But I read non-fiction a lot when
Nice.
I read.
Yeah.
And it's a little bit weird, but I read very horrible books. I have recommendations, but
Well, murder mysteries and stuff.
No, they're like, this happened in real life and this is bloody horrible. And
kind of more historical almost.
Yes. So Ordinary Men is one of those.
Oh yeah.
And there's another one. I don't remember what it's called, but it's about apartheid in South Africa. And follows a person who is slightly biographical, and it's just like crazy. And for me, it's like I have this thing that I think we live such easy life that you get like you get annoyed with first world problems all the time, and I just want to be try my best to be grounded in like the life has been generally just awful for most human history,
Yeah.
relative to us, and I just like to read about all of those kind of stuff that is like super bad. And also like I believe like Solzhenitsyn said, like the line between good and evil runs through the heart of every man. Like you need
Mm.
to understand the dark side of yourself to properly understand the world and everything around it. But that's like that feels like crazy outside the scope of this podcast, but that's what I read.
No, I mean
So
that's just yeah, kind of what I wanted to just kind of gauge your interest in different books and stuff. I know, yeah, again, kind of similar to you. I think like, well, actually, like going through like high school and college and everything like that. Like I did not read at all. Like whenever I had like reading assignments, I like skimmed it, read the bare minimum to like get an idea of what was happening, so I could like take the test basically. But then it was like literally like the week after I graduated college, like I just kind of had some time to kill. I ended up picking up um, the Ready Player One, which is that book that they turned
oh
into a
yeah,
movie.
yeah.
Um,
The
and
the mo- the, the movie is so much worse than the action than the book. I don't know if
I
you
actually
agree.
didn't. I actually didn't hate the movie that much. I thought it was
Okay,
a fun movie.
I
It
don't
was a
hate the
fun
movie, but I
movie.
like the book way more.
The book is absolutely way better, of course. I mean, it's like yeah, you have so much more
It's like
depth
The
that you can go
Martian. It's
into in
also a
a
very
book
good
and
movie, but
everything. And
the book is crazy good. Yeah,
right.
yeah, yeah.
So yeah, it was funny because it was like yeah, like literally like the week after I graduated, I read that, and then kind of started getting into a little bit of a reading kick over the next couple years. Read a good number of good books, a couple that I mentioned last week, and then I feel like I've kind of fallen off, and like now that I'm kind of in my new place and want to start getting into some new habits and everything like that, like I started kind of picking up reading again because I think it's just kind of like a good thing to do for a little bit at the end of the day. And yeah, so yeah, again, kind of wanted to maybe gauge your
I
if you had
have a
any good book
few
recommendations or
ones that
anything.
aren't.
And
Yeah, I have some that aren't like horrible or just like that. We can take one horrible book and then like we can take so the first one, which actually isn't horrible or anything like that, and it has with programming like tangentially, is Countdown to Zero Day.
okay,
Have you heard about this one?
I haven't. No.
No, I mean, I think that's probably my favorite technical book that's nonfiction ever. It's about like during the what would it be? The George Bush administration, NSA
Mm,
deployed a virus that basically silently disrupted uranium refinement in Iran, so they couldn't refine uranium for weapons grade use, and they
wow.
like made the world's most complex virus by far, and deployed it just to be able to delay Iran or Iraq. My ignorant self, like, but I think it's Iraq.
Yeah, yeah, yeah,
Yeah,
yeah.
Iraq from in there was like, oh, we will let you have this thing so you can have nuclear energy, but like US was like, no, we don't want to let, even though the international committee is agreeing to let them have this tech, we're going to sabotage it because we don't trust them to not develop
Wow.
atom bombs. That's basically it. So they like developed this crazy virus that they deployed in all sorts of ways to be able to fight off to make the actual physical hardware that doing the refinement not work properly and not refined uranium.
Dang,
And
fascinating.
there's like I can spoil everything about it, and the book is still like just amazingly fascinating because there's so much technical stuff in it. And it was like the old antivirus company, what was the name? Uh, Something
Oh,
with K.
Kaspersky?
Yeah, Kaspersky. They
I
had the
believe they're a
reach.
Russian company, actually.
Oh yeah, that might be true. Yeah, they had like a research group that dug into this virus
Yeah,
because it
yeah. They
was like
still have a
10.
very, very prominent research group, from what I understand.
Oh, right. The virus is like 10 times larger than anything else, and they're like, what the hell's going on here? And then they like just pieced to get out like assembly code until like Jesus Christ, this is madness. So Countdown to Zero Day, highly recommended if
Awesome.
you want to understand like, and this was like back in 2008, 7 that they
Yeah, yeah,
that
yeah.
this
No,
happened.
I love those kind of like modern history books where it's like, yeah, and especially because there's like, technology involved and everything. That sounds super, super fascinating.
Do you have any that I should read
Yeah,
maybe?
so last week I mentioned the Console Wars by Blake Harris, which I thought is a fantastic book.
Cons, like in
Console Wars.
console.
Yes, because it's the battle between the Super Nintendo and Sega
Oh,
Genesis.
oh yeah, I thought Cons of War like an anti-war
Oh,
book.
got you.
Yeah, console wars. Yes. All right. Yeah.
Yeah. So another good, actually super, super interesting technical book is one called I Am Error. And it kind of goes into a lot of the technical details about programming video games for the NES. And it's just like so amazing what they had to do with like, limited hardware. Because I mean, like, they're fitting like basically these like entire games like Mario 3 into a cartridge which has like a fraction of a megabyte worth of memory. And
Ooh, this one I want to read. Yeah, I can see
yeah,
now
it's
exactly what you
super
mean.
cool
Yeah.
how they like basically did like, data packing for if you're like in like a level in Mario, like they kind of have like some like, you know, 1 or 2 bit encoding that basically said, okay, here's like, one brick tile here, repeat it this many times kind of thing.
Yeah. Yeah.
So yeah, it's yeah, super fascinating. That's kind of a good technical book. But yeah, I mean, I'm sure I could go on and
Go
on
on. Yeah. Yeah. Yeah.
with book
If
recommendations
you
and
read a
everything,
few
but
books, there's like somewhere where it just explodes into like, oh my God, there's so many good books.
yeah,
Yeah.
yeah,
I think the medium of books will never be succeeded. It's
yeah,
like something different. It's just it's fascinating to me that we invented writing, which is so far has been the best way to convey complex information. Like even coding is in text, like it's
right,
just
yeah.
yeah,
It was one of those things like I heard something a while ago where it was like it seems like some of the oldest technologies are the ones that kind of stick around for like the
yeah,
longest amount of time, like things that like almost just can't be replaced. Whereas you see like newer technologies, these are things that kind of get replaced pretty frequently, and
yeah,
changed out. But there's something like books that are just kind of tried and true.
yep, 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 for sure, for sure. Oh yeah, nice.
All right. Well, that was exciting little warm up topic there. So now we can get into kind of the core of this show, which is kind of some of our main like Unity Dots topics. So this is super exciting. Something that I literally just found out about today, and this was posted yesterday as we were recording this, but. Unity ECS has a new sample project out. So this was posted by Philip. I'm guessing he was kind of one of the primary developers on this. You may remember we did have Philip on an episode, on our GDC recap episode of the Hot Path show a while back. So Philip, he's the developer of the rival character controller, which eventually got acquired by Unity and is now known as the ECS character controller. So yeah, he just posted this in the Unity forums about a new sample project, which is just this ECS Galaxy sample. And yeah, we're going to be going into it today. So yeah, you can check out the forum post here. I'll have a link to this forum post as well as the GitHub down in the description of this video. And actually, you know what? I have this open on my computer, so I can just go ahead and do a screen share. So cool thing about this project, I know some people have had some issues with some of the other sample projects, taking a long time to open up in the editor for the first time, or when you want to go to build, it takes a really long time. So really cool about this one. It only took like 2 or 3 minutes to open up. Build all the libraries and everything that it needs to. So, really not that bad. And then when I went to build it, it was another like 2 or 3 minutes. So, overall, it's not like a crazy big and complex project or anything, but there's a lot of really cool things that this sample project showcases. So yeah, just to give you kind of a quick overview about what this is, we'll just go ahead and hit simulate here. There are a bunch of different options that you can do in all this, but so yeah, you can see, I'm hoping this comes through somewhat decently on the stream and everything, but you can see that there are different like factions of these ships that kind of spawn. So here's kind of like the green faction, and you can see that this is just kind of dumping out tons and tons and tons of ships. I'm not sure how the physics of this works. Like how does all that how do all those ships fit inside there? But
Magic.
exactly. They're using some space technology.
Yes.
But yeah, so basically what happens is these ships kind of go out to these different little planet nodes, right? You see that, and then they can start kind of like harvesting resources off these planets. You can also see that these planets have like moons, and I believe they can kind of like build structures on these moons. And then, so yeah, they kind of start, expanding out into the universe. And then eventually some of the different factions will start getting close to each other, and you can see a little bit of explosions start to happen. Yeah, we see some like lasers and explosions going on. So they start kind of like battling each other. And there's a bunch of like different types of ships and everything. But so yeah, this is just kind of like an overview of the project. If I were to just, have a slight little bit of criticism on one thing, is just, this project is just kind of like a simulation that just kind of plays in the background. So it's not necessarily like an interactive game. Like you can kind of control the parameters about, how many teams and what's kind of like the, the max number of ships that can be spawned and everything. But you aren't actually able to like really interact with the simulation. You just kind of, fly your camera around and just kind of view things and everything. But again, a lot of this is kind of, simulation based and kind of meant to be optimized towards a simulation. So that's just kind of like maybe like one, a little bit negative point on it, because, most people are kind of like interested in creating games. Again, this is more kind of like a simulation type thing. But with that, there's a lot of really cool things that this project does to kind of like optimize it that I still do think translate over towards games, that we'll be kind of like getting into. So yeah, you can see there's a lot of cool stuff going on here. There's kind of like some, lightweight pathfinding where, the different ships are kind of like tracking down other ships and shooting their lasers at them. And you see there's good VFX of, explosions happening and everything. And yeah, I mean, it is like it's a fairly large sized, kind of play area. And, yeah, I mean, of course, like I'm streaming right now and it's in the editor, so that the frames per second isn't like all that good, but, I was running in a build of this, like not streaming or anything, with, like 100,000 units running well over 60 frames a second. So, yeah, I mean, it's pretty good for that respect. So, whoa, hello. So, Tobias, you got any kind of preliminary thoughts of just kind of what you see from this little demo project so far? Of course, before getting into the code and everything.
No, I think that's a very good idea to that's. I mean, I get that like it's a simulation, and your critique like maybe it should be more gamey, focusy ish, or something. I think it's a pretty good context to do something like this when you have like this 3-dimensional space thing with, as it looks like, not a lot of physics thing going on necessarily, maybe just raycasting. It's like showing off ECS without adding a bunch of other stuff into it, and I think Galaxy, a space type of fight, is a very good way to like, let's just not bother with all this stuff, which just takes a lot of time to do it. We just have points in space that attacks each other, basically. So I think that's a pretty good way of like, yeah, this is pretty straightforward to deal with, and we don't, and there's a bunch of different issues and domains of issues that we avoid because we're in space and we just attack. So yeah, I think I think it's a good framing of a good ECS/dots sample.
Yeah, totally. So yeah, and I was just doing a little bit of checking to see what versions of things it's running. So it looks like it's on 1.2.0. So it's not like the latest because there is a 1.2.1, but it is still in that 1.2 version. But yeah, interesting. There is no dots physics package imported in this project. So all the physics is fully custom, and some of that is kind of detailed in some of the documentation, which we'll be going over in just a sec here. So yeah, I wasn't sure if they were kind of tagging off of, like you mentioned, doing some ray casting or something. But yeah, it looks like it's all kind of custom built basically.
Yeah, that's I think that's a very good idea.
Because
There's
yeah,
like two.
basically for something like this, you really just kind of need like spatial querying. Like you don't necessarily need like two objects to collide and they like fly off in the perfectly accurate direction that they're supposed to or whatever.
No, yeah, and I think also like there's like just like performance can be very helpful to measure in context of everything or specifically exactly what you're measuring. It can also be very interesting to like uh, see everything in context with all the fluffy tools that Unity provides, or try to like just ECS with as little as possible and try to just like what can we do and how do we do it with just ECS, and like let's not introduce anything else that's not needed, and just like this is just ECS. How can we do something very fast, very cool, and very fast performance, and all through all the right pipes? I think that's a good idea. Unity sometimes I think it's a little bit of a just throw on tools until you can solve the
Hmm.
problem, and I don't necessarily agree with that a lot of times. So I'm all for
Yeah, I
like
get it. Yeah.
like what can we do with this good foundation and nothing
Right. Yeah.
else.
Because yeah, it's like if you just need one little specific thing, it's like if you're importing the full package, does that add any additional overhead? Especially with something like the physics package where you're kind of like doing all these physics steps every single frame when you might not necessarily need to take advantage of all the features and everything that it offers. Yeah, is it better kind of performance wise to just kind of like make your own type solution basically?
Yeah, 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 very much so. Yeah. It's an interesting question, and I think there's a lot of Unity programmers who haven't really like. There's a lot of like, oh well, we just Google on search on the asset store, or search in the packet manager. Oh, there's Unity physics, and we can just do that. Like no, like you can think about it in first principles. Maybe you can get away from it, and this project probably shows off a few things. Like this is you can just do it straight up. Just write the code that does it. You don't have to have a bunch of APIs and libraries for everything.
Yeah, yeah, totally.
Yeah. All right.
So yeah, I just kind of wanted to go into like a little bit of the documentation because it is very well documented. It gives you like a good overview about what all the main systems are and kind of what generally they are used for. So if you do want to kind of like replicate something on your own, you can reference the documentation and that gives you a good kind of starting place for things. So there is one just kind of like giving you a game overview. Again, this is just basically kind of like explaining what's happening in the situation. It shows kind of the different ships and kind of some of the different jobs that they have. And then, yeah, so this is kind of like the main portion of the documentation is this whole code overview section. And then this basically talks about, a little bit of what happens kind of like during the game initialization, what things are kind of like being initialized. This goes a little bit into kind of the theory behind authoring. I'm going to talk about this a little bit more in kind of the quick tip portion of the show. This is actually a super interesting thing, which goes into kind of our main topic of the show. By the way, did I ask you to give you a little preview about our main topic of the show?
No, it's fine. It's fine. No, should I
Yeah,
Blob
yeah, yeah.
assets?
Because yeah,
Yeah.
yeah, yeah.
Well, let's say like we talked about earlier, like yeah, maybe like blob assets is a little bit of annoying syntax, but once you get it, and we're gonna go through it, it's fairly straightforward. I think the most interesting part about blob assets is talk about like what's the reason for it, how do we use it, and where is the
Yeah.
pitfalls. I think I have a pitfall that you probably don't know, because I've used blob assets
Ooh.
the very very particular way where it broke down horribly fascinating.
Oh, no, okay.
Yeah.
Yeah, yeah, yeah. So yeah, I wanted to have you bring that up because yeah, one of the portions that they do mention is they have a blob data authoring that basically uses scriptable objects to bake them into blob data. So there is kind of this way kind of built into the sample project that you can reference that kind of shows you how to do that. So I think that was kind of something that is pretty interesting that maybe we could look at some other time in the future here when we might have a little bit more time for that. But yeah, I do think this is cool that this is kind of part of this little sample project here. And it kind of does give you some of the theory behind why they use blob assets, because it says, ships and buildings all have some data that is common across all instances and never changes per instance. So in this case, it can be beneficial to store that data in blob assets to, reduce the memory footprint, reduce the size of the archetypes and chunks for better performance in certain cases. And then, yeah, it kind of talks a little bit about, again, the theory behind taking those scriptable objects and baking it into, data to use in blob assets. So super cool. Shows kind of some of the, authoring and related systems and everything. And then, yeah, this is kind of like what I was talking about, how there's like kind of the different sections where, so, here's like planets. So if you want to, learn how, say, like the planets are doing specific things. This talks about, the different types of jobs that are actually being used to, handle this logic. Same thing for buildings, ships. It kind of like, goes into some of the, initialization and kind of their different, jobs that they can do and all this. But yeah, really, as we start to get into some of the more interesting parts of the documentation. So this is kind of the AI section. So the AI in this game is implemented using a simple utility AI system. So I know utility AI is something that I've been super interested in, just kind of like experimenting around with a little bit. So yeah, super cool that this project has a kind of low level utility AI system kind of built out where were you gonna say
Define.
something?
Yeah, I was just like simple utility AI. Maybe here is a situation where my English is slightly lacking, but like, what does utility in this context mean? Like, that just sounds like features for me.
Yeah. So I don't know if I could give a good definition of it, but my understanding of the utility AI system is basically like, um, a particular entity could have like some number of different types of jobs that it could do at any given time. And then kind of depending on, some of the, say, world state factors and, its own personal factors, it kind of makes a determination of, what job kind of has like the highest priority of something to do at any given time.
Okay. I completely understand what you mean now.
Basically, again, depending on where they are in the world, what resources it has access to, then it kind of makes the determination of what needs to be done. And again, kind of my understanding is this kind of like a high level AI for like a given team that kind of like says like, oh, we need these types of resources, and then it kind of maybe translates that down to some of the workers, and the workers say, okay, I need these resources, but like, oh, there's also this enemy close by, maybe I prioritize attacking the enemy. And it goes into like there's a bunch of different kind of like weight values that's how it can kind of like certain types of ships can favor doing one thing over another, and yeah, a lot of interesting stuff in here.
Oh, that's now I'm getting more understanding what you. It sounds surprisingly similar to what I did for Battle Right.
Oh, cool.
Yeah, yeah. So yeah, okay. I'm just
Yeah, I know there's been like some good like GDC talks and things like this on this concept of utility AI. So people can research into that if they're kind of interested in getting a better explanation than what I'm able to kind of come up with off the top of my head right now.
Yeah.
And then, yeah, it goes into a little bit of this entity initialization and death. So like just kind of, going through, a basic kind of initialize process. It's kind of interesting how they handled it is basically they have an enableable initialize component. And then with when that's enabled, which is kind of like enabled when it's first spawned. Then any number of different systems that have initialization logic built in will run. So that way you don't have to like create unique systems for each potential like combination of different things that need to be initialized. You can just kind of have very few systems, and then just kind of like whatever ones that it needs to run based off of its existing component makeup, it'll go ahead and run because that initialize component is enabled. And then basically at the end of the frame, that initialization, or sorry, the initialized component gets disabled, and then those systems will no longer run against those entities. So pretty straightforward, but it's just kind of like a nice, clean solution that I like. So yeah, here's where we get into some more interesting things with these acceleration structures. So this is where we start talking about this spatial database here. So the spatial database allows for fast querying of entities in a bounding box. So I'll just go ahead and kind of read a little bit of this to give you an idea about how they're kind of doing this spatial database and what it's used for. So it says the world is divided in a uniform grid of cells around the origin, and cells store information about which entities are within their bounds. Every frame, a clear spatial database system clears all the stored data in the spatial database. Then the build spatial database system iterates over all ships and all buildings and adds them to the spatial database. So which basically calculates which cell they belong to and then add themselves to that cell. So yeah, basically every frame, this entire spatial database is being recalculated. So you can kind of think of this as, again, as like a full kind of like three-dimensional, say, cube grid of cells. And then, all these ships are going to be kind of flying around this massive cube grid. And so again, every frame, it'll go through every single entity in the list and just say, hey, add myself to this, particular cell. And then that way, what you can do is now when you want to query it, you can use an access aligned bounding box to say, hey, find me everything close to this specific point within the bounds of this access aligned bounding box. And then basically all it needs to do is go to the small number of cells, and then it can basically return you that kind of full list of entities that are within those cells that overlap the bounding box. And then, if you do want some really, high accuracy, then now you can do maybe an additional distance check. So you're only really doing, say, a distance check on the small number of cells that you kind of get returned from that list, as opposed to, checking against all the number of all the number of entities in the entire world, which gets into what we kind of refer to as the n squared problem, where if every entity needs to look at every other entity, then that gets very, very costly, especially when you're getting to the level of tens and hundreds of thousands of ships in the world. So
I could add some perspective on this. Like the first there's like different levels of acceleration structures in complexity and stuff, and I would say that this type of a cube, or if you're in 2D, just like quad cell-based optimization, spatial fragmentation, as I used to call it. I don't know, spatial database.
Spatial database is how they say, yeah.
Yeah, I've learned it through, but it's the same thing. Spatial fragmentation, right, or database, yeah. I would say that depending on your level of understanding and where you are in your career or whatever, if this is something like I just like shove one of those in when I need it, then it's ignore what I say. But this is one of those things where you got to make your first spatial fragmentator or database and make sure you understand all the concept of it, and then like go through the next level of this would be a bounding volume hierarchy, which is what most physics which basically does the same thing, but it's like different trade-offs from runtime and generating in runtime or generating offline and then querying only and stuff like that. There's like not a billion, but there's a few different versions of this, and I would say that's like a rite of passage for a programmer. Like, I don't know if you agree, but for me, like I made my first one of these for Battlewrite for our custom physics engine that we made for it, and
Nice.
I just like wrote it with the help of a colleague who already knew we were like pair programming, and afterwards I was like literally like, if you beat the big boss in an RPG and you level 3 levels at the same time, it felt like I was like, Jesus Christ, it just blew my mind that we wrote this and it was so much faster. So
Yeah, no,
makes
that's something that you really got to do, and I think it's important to do it the naive n squared way first, so you can actually
yes,
see what the performance metrics are looking like inside the profiler, so you can maybe kind of recognize if that's a problem later on, and then when you actually go to implement your whatever, if you want to do like a quad tree or a spatial database or just kind of some type of thing to break up the world into smaller parts, and you can kind of query against those, and yeah, it is really night and day. Like it is pretty amazing because the end result of like what is happening in your game, it's like exactly the same. You don't see any difference in that sense, but you see the performance numbers and it's
it's
like
just
way better.
crazy difference. Yeah,
Yeah,
especially if you have the right sort of problem for it, then it's like, uh,
exactly. Yeah.
yeah. And I would just quickly another example of this, which I think is very fascinating. So people maybe have heard or maybe played Raft, the game.
Mm-hmm.
Worked as a consultant on that game for the last release, and I optimized their collision because the collision of big rafts were just unwieldy and very very slow, for obvious reasons, because it's just a big goddamn rigid body with like a million different colliders on it. So what I did was I baked the colliders to a single mesh collider. But then you needed to, maybe you have some sort of trigger, you have some collision events that you throw something at a box and it has a sound or whatever.
Mm-hmm.
Then that box cannot be, part of just one big collider, because then you can't
You
distinguish.
need to kind of differentiate that from like the
Yeah,
rest of the raft, basically, right?
yeah. So I made a very the sounds like identical solution where structure wise, where you were walking, I think like 9 times 9 meter sized boxes, and when you were in a box, it activated the actual collision, the individual collision for your box, and like I think 2 shells around you.
Mm-hmm.
So when you hit something, when you threw a shot an arrow or something, you hit the actual box that was, but everything beyond that was baked collision, just a single baked collision, and all of the individual colliders beyond that box was deactivated. So I only had the big baked collision, and then just a box around you where the actual individualized custom specific colliders were activated. And then when you build a new part of the raft, it momentarily activates, like builds a new version of all the colliders, and then like swaps it on the fly to the new one,
Oh,
and
interesting. Okay.
destroys the old one, and but still keeps like your box of individual colliders with custom actions active around you. And that would be
Cool.
one of those things where if you were to have to go through like, oh, I just built a new one, I need to like rebuild this situation and understand what I need to be active or not, then if you did that just as a list, then you would just spend like, I don't know, 100 milliseconds just going through like thousands of colliders, understanding what's close to you. So that was something. Raft runs faster with big rafts because of that optimization.
Oh, cool. That's
And that
that's
I
a
and that I baked the colliders into one big colliders. That
yeah,
that is
yeah, yeah,
the
yeah. I'm sure that
fundamental
helps.
thing. But that one doesn't. That one, was just something that built into physics. But and yeah, it was two-part solution there that wasn't required.
Yeah, no, that's a great use case because it's not necessarily something like that's like an obvious implementation of doing this kind of like spatial querying. Like of course, like for the example that we're kind of showcasing here, where it's this like big space war and things are kind of all checking against each other. You're like, okay, like if you're even like a little bit of experience, you're like, okay, this is something that like we're gonna need to optimize. We're probably gonna use some spatial querying of some sense. But yeah, for the use case of the raft, that's not necessarily like an obvious use case for something like this, I guess.
Yeah, yeah. When I looked at in the profiler before I went on to like find out exactly how I was going to do it, I was like, because there was so many individual colliders attached to one rigid body, it was this specific is not really relevant, but it was like a big spike in one part because there were so many individual ones. Now I was like just Googled through the different APIs in physics, like, oh, you can bake this. Okay, we got to bake it and we got to make it like seamless. So when you build and destroy your raft, it just seamlessly adds and removes stuff to your baked big collider. And then like Semi, who is the programmer, he was like, well, you should still be able to interact with the stuff that actually have unique things. And then I was like, this will just break if we do it in a naive way. And but for me, it was just like a hammer in my toolbox. Okay, we gotta spatialize this and do it like that. So now I think if you have a stupid big raft, you can get a slight lag spike when you build a new part because it needs to like rebuild everything.
Okay.
But that's physics that needs to rebuild everything, and it's fair enough that it
That's
lag
that,
spikes a
that's
little
end
bit.
game. If you've gotten that far in the game, you can deal
Yes.
with a little lag spike here and there.
Yes, I remember when we put it in and we had like some save file from some player who built like this gigantic thing, and like we can test it with this and then we can see if it's better or not. And we had a big improvement. And then I wrote to him like, oh, I can't wait to release this and see how people react. And Semi just wrote back to me, it's like, nah, nobody's gonna care. Players aren't that, they don't care about this. And I was like, in my mind, I was like, yeah, he's probably right. But in my heart, I was maybe somebody would care. And then when we released it, we got a comment on the Raft Discord, which was like, "Oh, my what do you call it? The boat that has like jets taking off from it."
Aircraft carrier.
Yeah. He like literally built an aircraft carrier raft. Yeah, and like, oh, my aircraft carrier is not 8 FPS anymore; it's 35. And I was like, that's it. That's my optimization. So I just celebrated with a shot or something. I don't remember, but I was very happy that he noticed that.
That's awesome. So yeah,
All right.
spatial databases extremely useful. So yeah, cool that they have one of these. Oh, this is a cool thing that I really liked here. So this says for the spatial database entry in a cell. So again, this is where it's a storing the individual entities to say, hey, this ship with this entity ID or whatever, this is in this cell. So also alongside that, it sells a single byte for the team that it is associated with, and a single byte for a byte type. Yeah, so the basically the type of ship. So that basically, when you go to do your spatial querying to say, find all the enemies nearby me, you can basically kind of filter out at that stage for entities that are on the same team as you, because of course you don't care to attack people on the same team as you. So you can just kind of check that one byte to see if it's the same as your own team byte. And this kind of means that you don't have to do an additional component lookup where you have to say get the entity and then do a random lookup to find the what team that's associated with. So that can end up being a little bit costly because it is kind of a random lookup at that point because you have to look out into another place of memory. So again, what this is doing is it's basically just storing a single byte for whatever team it is and another single byte for the type, because again that kind of goes into some of the decisions that are being made kind of during the whole AI process. So I thought that was a cool optimization to just kind of store that data there so you don't have to look out elsewhere for it.
Yeah. Yeah.
And again, this kind of goes into some of the other things. So this planet navigation grid. So again, it kind of uses another kind of spatial querying database here, where yeah, each cell computes and stores data about the planets that are stored closest to that cell, so that I think yeah, this kind of goes into some of the planet avoidance. So I suppose that the ships know kind of where generally where planets are, so they can kind of avoid them, and again, not having to do any additional lookups there. And then finally, it goes into talking about the VFX. So this is kind of an interesting setup that they had to do because they, quickly mentioned that if you have hundreds of thousands of units attacking each other, you don't want to spawn a single, VFX graph game object for each of those, instances of things happening, because that's going to be a massive performance bottleneck. So, yeah, they say they use a mostly game objects less approach, where every instance of a given type of VFX is handled by one single pre-instantiated VFX graph in the scene. And then each VFX instance is basically a spawn VFX here message. And that goes to the VFX graph object through the graphics buffer. So again, that kind of allows you to spawn a very large number of VFX elements very often at a very little cost. And again, it does kind of mention that the systems that are used for kind of doing this. So if you are looking to do a lot of VFX very frequently, this again is a good kind of sample for that. So thought that was super cool.
I need to look through that specific example there because that was what I was intending to do for just read instructions.
Hmm.
But when I made my version of it, I think maybe 2 years ago,
Okay.
there wasn't there wasn't like a way to communicate multiple instances of the same effect
Hmm.
through one instance of a game object that plays. So you had to have a game object for everyone. There was like in the API there was like a clear cut way, like this is, you're supposed to be able to play this game object VFX asset and then just push like GPU events with a position and a rotation to it every frame. Or not every frame, but whenever you want to spawn an additional, and then you set up in the graph, so you spawn an individual effect, new one, every time you send that GPU event, which means that, like they described, you only have one game object, and then you have a new effect on the GPU spawning every time you push out one of those data blobs, whatever. But that thing wasn't like they explicitly wrote in like a forum post, like, yeah, that's what the idea is, but we don't have that support right now. So hang tight. ETA, I don't know.
ETA TBD.
Yeah, yes, yes, soon, trademark.
And actually, yeah, one thing that I wanted to just showcase real quick because I thought this was kind of cool. This has kind of some of the debug views. So yeah, I'm guessing it looks like there's maybe some debug views that you can kind of like enable in the actual simulation. But yeah, here's kind of the spatial database. So this kind of gives you like a visual of what the spatial database looks like. So again, it literally is just like a bunch of cells kind of scattered throughout. And then you can see, I'm guessing these cells that are kind of highlighted, those are where kind of like things exist.
Yeah,
Those look to be kind of
looks
like
like it.
planets and stuff. Yeah. So yeah, you can
Yeah.
see that this basically covers, the entire space of where, anything could be. And then, again, cells are kind of being, or entities are kind of being entered into those different cells as needed. Here's kind of the planet navigation grid. That's kind of a crazy looking one. So again, this is kind of determining what the closest planet is to any given cell so that any ships can kind of like avoid them. So I'm guessing these are kind of like the white lines are just kind of like from the center of a cell to the closest planet, basically. Here's the planet's network. So these are kind of the closest, the top number of closest planets to whatever given planet.
Ooh,
So
I'm
yeah,
getting traveling salesman vibes.
yeah, totally right.
I think there's a fundamental lesson to learn from this, or to take from this. Is like which I got shoved into my head early by Rasmus on at Stanlock, who has been on the stream. Uh, make the debug visualization or the debug tools before you make the feature. Like maybe
Mm,
that's a little bit extreme sometime, and maybe that's not the case here, but you can obviously see that he spent a lot of time to make sure that you can visualize what's going on, because like there's so many times where I looked at my own code or other people's code, and you try to go through it, and then like either me or the person who wrote it or whoever is like very surprised what's actually going on. Like, oh, this is not actually doing what I thought it would be. It sort of works, I guess, but but if you sort of develop the tools to view your data properly uh, before or alongside and
yeah.
very heavily push that in, then I think it's like the development time becomes more predictable, because you're going to spend some constant amount of time on the development tools for it or the visualization of it, uh, but also the actual feature won't be like a high risk high reward type of a deal where you just implement something and hopefully it works. It will be like, well, we spent like almost the same amount of time on making sure that we can understand what we're doing, and that means that will take like maybe twice as long as time, but the like the variability of how much time you're going to end up debugging everything, it just shrinks to a constant time. Like, okay, we're going to 2 days and then it's going to be fine. So then you can sort of make the burn rate of your implementation more predictable by just making sure that you just develop the debug tools and visualization for it very early.
Yeah, that's a great point. I guess that's something that I've just kind of like naturally just kind of done, just like I guess in general, like as I'm going along, I usually like to like print out debug statements or just kind of have like little intermediate steps to make sure that I'm like, on the right track. I don't know if I'm necessarily like, put words to it that, like you say, make sure you have those kind of debug and visualization tools first. But I know like when I've in the past done some kind of quad tree type things, it's been extremely helpful for me to early on draw these things out to the screen, draw relationships between different things, just to again make sure that I'm going down the right track, because something like super kind of like abstract with all these like algorithms that you may be creating to create these spatial structures, you know you, it's difficult to verify that it's doing exactly what you think it should be doing,
Yes.
especially just by looking at it, because again you could say run the simulation against your data and things could start kind of interacting in some way that kind of looks right, but you don't really know. So that's why it is super important to kind of have like actual visual debug tools to show like, okay, things are being entered into this cell, and if you're doing any kind of subdivisions, make sure they're actually subdividing properly and everything. So yeah, that
And
is
just
good advice.
writing some of the bug tools or visualization things will the act of writing it will sort of reveal logical errors you have in your own thoughts. Sometimes you're like, wait a minute, this is like a one-to-many relationship and I thought it would be one-to-one. I thought about something wrong here, and then you're like, and maybe that's way before you got into the point where you run it and try it, and you're like, I'm just off base here. This is not how it's supposed. So yeah, I it's and not something I do on a game jam, but otherwise I'm like, yeah, let's make
Well,
a
yeah, I mean, especially if you're doing something new, it also like really just helps you like kind of understand those concepts better. Because again, if you're building this kind of step by step and you're like kind of seeing how things progress along the way, you can see that when you add a new block of code, you get like an actual visual, of what that block of code does. So I think it helps you kind of like intuit the things a little bit better, kind of the more you do that.
yeah, like John Cormack said on the Lex Friedman podcast, like he like when he implemented something, he just connected the bugger and stepped through the lines before he even tries it. Really, he's just like,
It's such
well,
a smart.
I'm
thing to do.
I'm probably
It
wrong.
really
I
is.
probably made 5 mistakes already. So let me just step through every and just like this line, execute.
It is, yeah,
Does
it's so
Is the
amazing.
return value correct? No, it's not correct. What I expect, I made some fuck up. Let's just stop it and just start
Yeah.
debugging or start writing it. Yeah,
It's so amazing how many things you can find just by doing that.
yeah. Just stepping through it and like understanding what's going on. But also like that's it's a slightly tall order if you work with a heavy engine development environment like Unity, where you sometimes wait for a minute for the debugger to connect properly.
Right.
So I
Yeah.
guess well, yeah. But one can dream.
All right. Yeah. So, and then, yeah, I think we're just going to kind of close out this section here by doing our cache hit, the Unity Dots quick tip of the week. So, one thing that was kind of mentioned in some of the documentation of this that I thought was just like a good kind of thing to point out is just kind of a good PSA slash reminder that, these authoring components that, we use to again take basically data that we can configure and set in the engine super easily over to baked data over on the ECS side. I just want to again PSA and reminder that these authoring components, they are just regular mono behaviors, so they can basically have all the same capabilities of everything that our regular mono behaviors have. So one of the cool things that this project does, which is something that I've used in the past that has been very helpful, is using the require component attribute. So basically, for example, we have this say building authoring, and you can see that we're doing a require component against a bunch of other authoring components. So we can say, hey, if we want a building, like, yeah, let's just go ahead and drop the building component on here. But also, our building needs to be associated with a team. Our building needs health. Our building needs to be initializable. Our building is an actor. Our building needs an entity name. So, just by adding this building attribute or building authoring component onto one entity, it adds, what is this, 5 or 6 other authoring components just right through there. So that now when we have systems that run against something that we presume to be a building, we can pretty much guarantee that our building is going to have all the other makeup of components that we expect it should. So I think doing something like this is super simple. It takes 2 seconds for you to type out require component type of whatever, and it could save you some trouble in the long run when some system isn't firing against some entity that you think it should, or things like that. And again, just because it is a mono behavior, you can basically do anything that you want with the different public fields. One thing that I've had a lot of success with is using the custom property drawers, where you can basically make, say, like if you have, say, this is this say building data object type, right? You can make that show up in a specific way in the editor. You can maybe have multiple field parameters. You can create a slider, or if you have a more complex struct, you can kind of display those values in a specific way in the editor. And of course, you can go even a step deeper and make a fully custom inspector based off of these mono behaviors. So a lot of powerful things that we can do. I know some people are kind of annoyed by authoring components and just kind of some of the overhead that we have to do to create all these when we just want to do one simple thing, like just adding one value to a data component or something like that. But there are a lot of really complex and powerful things that we can do with them. So just kind of wanted to shout that out real quick. So I think with that, we can kind of move into the main portion of the show here for the instruction set. So Tobias, you're going to be giving us some little overview on blob assets in Unity, ECS, and some of the use cases we have for them and everything like that. So I'll let you take it away.
Yeah. Blob assets. First time I heard it, I read through the documentation or whatever, I was like, what is this crap, I have no idea what's supposed to be about it, and like it just looks obtuse and annoying to work with. Let's just ignore it for a year. That's basically how I viewed Blob assets when I started with ECS. But as you can read on, if you look on the ECS documentation for Unity, like Blob assets represent immutable binary data. So blob is like this word that the whole sort of tech community have chosen for data that's like
I think it's
not.
a binary large object.
What? I didn't know that. Oh my god, blob. I thought it was just like a cop out
Yeah, you're
to
just
like,
like a blob.
like when you name
No,
something. Well,
because
it's
this
an
this kind of comes
algorithm.
from like the IT world. Like you talk about like blob storage for like backups, binary large object.
Binary large. Well, I guess the acronym would be slightly more reasonable swapped around, but they probably made it in order so they could say blob. Large
Yeah.
binary object would
Yeah, right,
be, but
right, right. Yeah. Blob sounds cool
LBO
better
is.
than like a bulb.
Yes, exactly. So yeah, okay. I had no idea actually. I'm a little bit confused that I haven't noticed this. Well, I mean, now when you have told me, I'm gonna see this acronym spelled out
Yeah, right.
everywhere. Yeah. Anyway, so by immutable binary data. So for like this thing with immutability is like a thing. If people, for those who haven't really gone into it, I recommend hardly very much to like, I don't know, Google. I don't have a specific resource or anything, but Google like immutable but versus mutable data in programming languages. Like maybe Rust is a good example of stuff that where everything is immutable by default. You need to like say a variable is mutable, and so there's plenty of reasons why immutable data, data that is like enforced by the compiler to not be able to change at all, like yeah, nothing can change the value. But there's several different reasons for it, but one of the main reasons for immutable is that it's if it doesn't change, then you are very sure that all the threads, all the cores can work with it, and they won't have any problems or race conditions because they can't change it. They
Right.
can't be touching the data and doing stuff in weird orders, in random
Yeah.
orders,
And
and
they don't
do.
need to check. They don't need to check to see, if anyone else is accessing it. It's guaranteed by default. Yeah.
Yeah, it's like this is the way it is, and there's no way around it. This data will always be like this, and you don't like. There's no need for doing any extra processing around it. You just read the data, and that's it. So I'm not familiar enough with the definitions of how C# works, how Unity's implementation works, and all of this to exactly know how this works. And it's hidden behind C++. I think a lot of it. But blob assets is Unity's way of like, here you can have a data that works well with all our whole ecosystem of processing, and it's immutable, which means that you can create it once and you will not be able to change it. Our API will make sure you don't change that data, and you can shove it into all the jobs that you want, however you wish, and it will always just be thread safe by default. Not even by default, there's no other way. There's like, this just is the data just is like if you declared a constant in C#. So that's what blob assets is. So imagine like, so a few examples of data that will go into blobs if you wanted to, or will conceptually fit very, very well into it. And I'm gonna take this as there's a few example where I use blob assets for just read instructions, my game that I released a few months ago. So maximum health of all the characters, or all the things that you can actually that has health. So, and damage, how much damage a specific projectile makes, and it can be a range. Maybe there's a specific reason why a projectile can have like a can increase or decrease in damage, but that range can be stored in a blob asset. um Speed of stuff, like anything that just like you declare it, you change it. normally in the editor through authoring components or
Right,
whatever.
right, right, right.
But then you just
But once it's set, it's set.
in runtime you push it into a blob assets, and then that's that. And so part of the thing with blob assets that's very relevant is that it's like isolated and self-contained. So that means that it's inside. The only thing inside of it is data, and it doesn't point out anywhere. So it doesn't like involve anything else than exactly what is in the blob data. So you can't like escape from whatever you are through data inside of a blob asset. It will just like, this is an integer, and this is a float, and this is a whatever, and you just use this. There's not like, oh, this is an object and it's over here in the memory. No, that doesn't happen. So that's a few core things, and I just thought to show this off, we'll just take a look at the excellent sample project that Unity included into ECS. Because I was like going preparing for this, and I just like looked through a few search for blob assets examples to like get some inspiration. Then I noticed they already have everything basically in the default, so it's just double work for me to write anything else. So I'm gonna add stage and do this. Is it properly showing?
Yep.
Yes. So this is, so first of all, I thought it would be a callback to an earlier episode where we talked about this, I think. So blob asset examples, which is located here in, we can see, I don't know if this shows up properly.
I can see it. I don't know if it'll go through on stream, but
yeah, but it's like in the entities folder.
the ECS samples, or
Yeah, and
the actual, is it on the actual package?
yes.
Okay.
So that's what I was surprised about. This is a very clear-cut example in the actual ECS package in doccodesamples.test. Part of this is just, you should just try this out for yourself with all the code and try to write it and understand where the limitations are, because it's a little bit like it's a little bit esoteric, if that's the word you could use, with how you construct it and everything. I'm going to go through how it works, but you should really try it out by yourself to understand it. I think the knowledge that is actually a little bit harder to get a hold of, I think, is to actually understand where you can very much utilize this. So I'm going to focus on that, and probably you, Johnny, is going to have a few nice inputs on it as well. But let's just go through what's going on here. So here you have a straightforward, you have some market data here. You have some price of oranges and apples. Very, very simple example. So you have a builder, and this, you create a builder, and this allocator temp here, it's just for the builder, and the builder will be gone when you're done with the construction of the blob assets. When you're using the blob assets afterwards, this builder is irrelevant.
Right. It's almost like a string builder or something like that.
Yeah,
like you're just using it to generate the final output. It's not the actual final output.
Unity could probably have made this a class and not have an allocator here, but then you would allocate garbage, which the garbage collector would do, and they want to be able to do. Obviously, they are doing the right thing. I'm just pointing out that this doesn't necessarily need to be this specific allocator, where they probably allocate C-type memory for this. But when you build this builder, then you can construct a route, and this route is like, this is where they just like lay out the exact memory to be able to fit this, right? So they just like, oh, we need 2 floats, so we allocate these 2 floats, and then we add, and this reference means that we aren't looking at a copy, because normally a struct would be a copy if you would like, just set copy. If you have this market data and you have an instance of it, my market data A, and you put that into market data B, then market data A and B are 2 copies of market data and not pointing to the same memory anymore on the stack, actually. But with this ref thing, you actually point to whatever exact memory address was constructed with this construct route in the builder. And then you use this and use it like a normal thing, and you set whatever values they actually want to save. And these are the values that's going to be completely constant. You will never change them. The only way to change them is to reconstruct the whole blob asset and replace the old one. and then you create the blob asset reference here, uh, and now you use the persistent one. And I don't know if there's a situation where you would not use persistent, because blobs would generally be something that is persistent through your whole
Yeah,
applications.
I mean, yeah, you could create, a blob asset inside of a job and just use it inside that job, where you might want to use temp job memory, but I don't see any like
No, it's very, very strange
I
usage
wouldn't
of
see
it.
anywhere where that would make sense to do that instead of just using
Yeah,
some other type of memory that is by nature going to be disappeared anyway. So
yeah. So so it's constructed with persistent, so it stays allocated through the whole runtime of the application. And this thing that you get back here, it's uh, blob asset reference with the specific T. We can write it out here. Blob asset reference, like that, so it's easier to see what's going on.
yeah,
So this means that the variable you get back is not the actual value, but it's a reference to the value. And this is where the thing that I said to you, like, I don't know if you know this, I'm going to show you an example where this type of thing breaks down in a way that the compiler and nothing like prepares you for. And I had to fix this because the way that it's referencing the actual data is like through a reference. It's a pointer, but
yeah. I was just gonna say, yeah, it's basically a pointer to the data that you're allocating again up in the step 20 or line 27 there.
yeah, exactly. And I think also, like, I'm not sure, but I think when you build this, and actually, I'm getting more unsure as I speak about it, but maybe this is actually sort of an arena allocator, which allocates all of the blob assets in a big space, that, or maybe they have a few spaces, and when they run out, they allocate a new one. But I think most of the blob assets are like generally collected into one area or something like that. Because this pointer could, point into a space where they're like, oh, here we got a few kilobytes over for whatever they decide to allocate as blob assets. But I could be wrong on that. I know I read something about how you can like
Like there might almost be like a chunk dedicated to
Yes.
blob data.
Well, yeah, a chunk, not an actual ECS chunk. That would be something different, I
I
think. Or
I use the term chunk as
yeah,
more just to demonstrate the concept rather than
yeah.
like the actual yeah
I figured I was just so the audience understand that we're not meaning like an
yeah
actual ECS chunk with
right.
ECS objects in, but yeah. So this one references that. So that means that when you're using this one, there's no price orange here, but there's a value, and inside of that you have the actual values. So this value is like a T that's using an unsafe utility thing here, where it's just some gibberish to get specifically to a pointer,
Right. Yeah.
not to a pointer, to wherever this blob asset is pointing to.
Right.
So anyway, so that's a little bit tricky, and I'm going to show where, like I said, where it breaks down here. But after this, you can just take the builder and you can dispose of it. And I would say that this example is a little bit unnecessarily, because you can do like this. I don't know if you know that, but
Oh
that
yeah,
will
yeah,
work.
and it'll
Yeah.
automatically dispose. Yeah.
So for the people who maybe haven't used this, normally you do something like this. Probably this is also a completely valid way of doing it, I
Right.
think.
Yeah. You specify the scope. Yeah.
Yeah, so I think the blob builder implements iDisposable probably in the end somewhere. Yeah, iDisposable. So that means that you have a disposable thing that will be called. Oh wow, it's just forgot all the coloring for there. That means that the dispose function on this builder will be called when it goes out of scope. Well, you don't have to have a scope for it. You can just do this, and it will automatically treat this function as the scope, or at least the rest of the function wherever you declare to use
Right.
it.
Yeah.
Yeah,
When that function goes out of scope, then anything that you have the using, and then anything that is disposable or iDisposable, yeah, it'll clean up.
yeah. So yeah, so that's the way, and let's just look through two other examples here, I think, which is relevant. Oh, wrong one. So that's how you create it, and you can place this wherever you want. Just make sure you place it as the blob asset reference to the object, not the actual object itself, because that
Right.
will
Yeah.
break
So
down as that one.
if you wanna store that in a component, yeah, you make sure the component is a blob asset reference of type, market data or whatever type you want, exactly like that. And then that now can be stored on an entity.
Yeah.
But again, yeah, you're not storing the underlying data, and yeah.
Yeah, so this means that this here you have like an I component data. This means that this variable, whatever you put into happy pool, I don't know what this is. This is an array apparently, but if you have like a million things or 100,000 hobbies in this hobby, um, you are not going to store 100,000 things
Right.
inside of this. Here we go, in this
Yeah.
component. You're just gonna
Again, you're just
store
to
the
the
reference.
pointer of that data or the beginning of that data if it's like a blob array.
Yeah. So that's how you can you can just shove a lot of shared constant data, balancing data like max HP, start HP or whatever, and damage and movement speed and all of those nice things that never change or usually never change in most games that uses them. So you just shove them all into a nice blob asset, and then all your different entities use the same blob asset reference to or not they use the same blob assets, and you just reference the same blob asset for all of that data.
Correct. Yeah.
uh, and that's very efficient for a lot of ways, among them like cache efficiency, since you don't have to have more allocated, you don't have to have this data allocated for every single entity, right? uh, and this isn't really pretty straightforward. It's just get exciting hobby. I haven't actually read through this one, but get exciting. They are doing something. Well, it's just a
You're
look up.
getting an exciting hobby.
Yeah, I don't think it's really necessary. I think you're gonna figure it out when you go through it. But I thought I would just show off the array, because I think that's probably relevant. So array is a little bit interesting because array, you use blob array inside of a reference. So that means like you get a nested situation. This was something that bothered me for a while. I didn't really understand, but um, if you have like here a bunch of hobbies that you want to save into something, you construct the builder like normal, and you construct I would think this is so this is a struct. So this struct has nothing to do with the fact that it contains an array. This is just a struct like the
Yeah.
earlier
Yeah. Yeah. Yeah.
example. Yeah,
Yeah,
and then
yeah, this is where blob assets start to get, I think, a little bit confusing, just
yeah,
because, yeah, it's like
because
the
it's
kind of
nested
the
in a weird
ordering of
way.
the types, and yeah, things are kind of nested, and yeah, building it is weird, accessing it is a little weird. So
Yeah, I think also this one is more confusing than not to have this constant all of a sudden here. This constant here is irrelevant. That's just a number that they like pointed out that this is could be a constant value, but it doesn't have to be. This number of arrays that array
right, yeah,
element that you
you
put
could
in,
get that from anywhere. Yeah,
you can get it from runtime execution. It's just that when you have generated your array, you're gonna lock that in, but
right,
you can calculate this or get that value from anywhere.
right.
Yeah, but like we said, we construct a builder and we construct a root for the object that's gonna hold, and this just happened to contain a blob array, but there could be like a bunch of other floats value here. If I could, but
Value.
value. It could be other stuff here. It just happened that this example, they want to show off the array, so they have this one. But this one needs to be inside of a blob asset reference.
Right.
So
Yeah,
that's
and yeah, that could be useful too, where you have like, say like a speed value, and then you also have, your array of hobbies or whatever. Like,
yeah,
you could, yeah, store multiple things that are all going to be kind of accessed generally around the same time.
yeah. Like we got a bunch of different We have a bunch of different speed gears in our car. We got a eight speed manual transmission, and all of them got a ratio and like a whatever, and then you can store all of them in a blob array like this because
Right.
they don't
Yeah.
change.
Yeah.
But then what you need to do here, you get another thing here in the blob builder where you allocate. So this like this is where it's just tricky. You just have to do it a few times to understand, because like the intricacies of this is just a little bit strange. You put in the reference to the inner blob array inside of a blob root that you already constructed earlier. So this is the one that where you can like we talked about value here that I just constructed. You can put that's the thing we did earlier with the oranges prices and stuff, but you also have this inner blob blob array roots, and that you need to construct in with this specific one. So you should just refer back to the documentation whenever you're confused, because this confused me in the beginning, honestly. And then you use this one, which is a blob builder array reference, and you use this one and you set in the actual values
You
into the
populate your
array
Yeah.
that you want to lock down. And when you put in the values, then you can call this one again, the create blob asset reference with the persistent one, and all of this stuff is going to be locked into the results.
Right.
So
And just to remind you, when you're populating that array, you can do that inside like a for loop if you want to, where if you like have some source array, you can populate that data into your blob array.
yeah, from like a list in your authoring component or whatever.
Exactly.
It can be it can be dynamic data. It's just when you put it in and you create it, then it's locked into that particular data set or data blob. Yeah. Anyway, so that's also, and then you got the string, but it's like, honestly, you should just look through the allocate string. There's also like a specific like version of the allocator where you allocate some specific data inside of the blob asset root or the thing and the blob string. But it works I bet this is basically a blob array with just characters inside. So probably like just a wrapper around the array, but the array is just specified to be characters, so it becomes a string. So, but these specifics aren't really that necessary. Like I said, you should just look at it and you look at the documentation. A few thoughts around this that I wanted to bring up here. So, first of all, this is contiguous memory. I don't know if I pronounced that correctly, but this is memory that like lays out, this builder will lay this out contiguously in memory, perfectly straight. And that means that you can serialize and deserialize these blob assets very quickly. And that's what Unity does. I don't remember, but I think they have a few examples where isn't like part of the subscene situation, like they just serialize a big blob assets in some cases.
I do not know.
I think there's maybe not subscene necessarily, but I know that Unity has a lot of situation where they like, well, this is just values. Well, honestly, like blob chunks or ECS chunks are just values. It's just arrays with a lot of values. So you can shove that into. So if you reframe it like a blob asset, you can serialize and deserialize this very quickly, because serialization fundamentally goes super fast if it's not a scattered type of data. So it's you're not building up a spider web of complex data interaction. If you just have a bunch of values in a row that you need to store, then you can put them in a blob asset and serialize that blob asset, and that's very, very fast to both load and save. And now I'm a little bit confused. I don't remember exactly what the serialize. Yeah, serialize. No, this is not the one. I should have looked this up before. But blob asset serialization is a very big deal. That is a very good thing, because remember, like It's because it's just contiguous memory, and the computer is super fast with linear memory. This is very prominent, very, very efficient way of dealing with data that you need to store on disk. So, and that means also, like, for example, you could have a situation, and this is the thing that I think Unity does automatically for you in some of the ECS situations, where they like you can do this manually, where you have a bunch of data, you edit it through authoring component in the editor, and you have the baker and everything, which lines everything up and makes it nice and tidy for the runtime. But when you build, then you can have like a build script which takes all your constant data, put it into the blob assets, which you use in runtime, and serializes them to disk to a file. And then when you press play and you start a game or start your application, then you deserialize that blob asset, and it's just like a binary data that you just like basically just move from a file into your RAM, and there's zero processing with it. You just read the file into RAM, and it's already exactly the layout that you're going to use in runtime. So the loading of this constant data is just lightning fast. There's no processing anywhere because the blob asset is just binary data straight up. Does it make sense?
Yeah, totally.
Yeah. So that's one of the things where it's like, I think I reduced the loading in just read instructions by a few times by just using everything in blob assets. So let me show you a few situations where I use it in just
I was gonna say, let's get into that.
Gameplay data. This is the root of everything, and this is a component. And if we refer back to the other one, it was referring to the actual blob assets, the inner value here. And here we have my whole game's constant data.
Oh, wow.
Yeah, so that's how I store it. So everything here, so like the shotgun data. If we go here, we have like offset, spread, count, magazine count, magazine
So it
rolling
goes really
speed.
deep. I'm just curious, do you know like the size of like what that is in memory of your whole blob asset?
Barely a kilobyte, I think. It's just very, very tight.
Cool.
It's
I was
not
just kind of curious.
Yeah, it's not a lot. The animation curve blobs, which contains a blob array, sort of spreads it out a little bit, but it's not that much.
But yeah, I mean, you're storing the blob array, and then it's like, yeah. So.
Yeah, I don't think it's like necessarily just a kilobyte now when I think about it, but it's definitely not a megabyte. Not even
that would be a lot.
Yeah, that would be a lot. But it's like, but all of the constant data in the whole game is less than it's just shoved into one of these, and there's no duplication of it. So everyone is referring to the same blob asset. So so that's a use case. So if we take a look here, this is my singleton, and this is loaded as I spoke about, just straight in, super fast from a memory. No, let's skip that piece of the code. That's not really relevant. But I get it into the game, and when I read it, this is where it's a little bit tricky because I get the singleton, this the component, right? The I component data, and this is the value to the blob asset reference. So not the value that the blob asset reference points to, but like my instance of the blob asset reference.
Right.
So yeah. So and then I have this data, and we can maybe take a look here. So we have spread. So we lerp between max and minimum spread based on a power value, right?
Yeah. And you can kind of see one of the sort of annoying things with blob assets is just kind of how verbose this gets. So you have to say, data.value.shotgun.spread.min. So when you want to get to the actual specific piece of your data, you kind of have to go through that like hierarchical step there.
So here's one of the, and this is maybe now when we talk about it, this is obvious to you, but this, here I can get the actual inner data. So this one points to the big array that I showed you.
Mm-hmm.
Not big array, big structure with all of it. If I do like that, I should, in theory, be able to, reduce one of the values on all of these.
Right.
And that works fine compiling wise. But this means that this screws up everything because of the reference type of dealing with this thing. It just doesn't work at all. So this data, which is, just, I don't know how to explain this. Actually, it's a weird thing where if you just like pick out the actual data out of the asset blob asset reference, and you move that and you make a copy out of that, then that doesn't point to the same thing anymore, because you're not copying the data inside. You're copying sort of the reference, and now it points to something else for some reason. So this one just points to gibberish now.
Interesting.
Yes. It's very, very strange. And I think it has to do with because when you have this thing where it's like a reference, like this one, the T here, that points to somewhere, the value here, this is relative. The pointer is like relative inside of the blob asset. So when you go to a specific value inside here, so the shotgun inside of this inner data, this thing, it's not relative to the original object anymore. It's relative to somewhere else in the memory, where it's like a copy of the reference, but not a copy of the actual data.
Oh, weird.
So it's a very strange thing. So I guess the thing we can say about this is like, blob asset is very powerful and very good to use with multi-threading and with deserialization and serialization, but there is some magic trickery around it where you need to keep your head level and understand that some nesting like this can be a little bit weird. So that's this long thing here, data value dot shot. I haven't done that because I think it's fun. I've done that because I couldn't make it work in other way. So I need to revert this back so it just dot value.
Is
So
that
I'm
the kind of gotcha that you were referring to a little earlier
Yeah.
about the weird situation? Okay.
Yeah. So that's how I use it. All of these guys. So you can see here, if I go find references, my whole every
It's like
system,
you use it a couple times throughout your
Yes.
project there.
all of them. But remember, all of them just points to the same part of the memory.
Exactly.
So
Yeah.
I bet my
Yeah,
constant
doing
data is pretty
redundancy or
cache
anything.
efficient. This is actually, I'm gonna see if I can look up how I actually declare this and see if I load it in as I remember, or if I have another. Let's see here, blob assets. But this is the bake. This is a normal baker where I bake and I go through all of my scriptable objects. So all of these are scriptable objects that gets baked into the yeah,
Cool.
it get
So
baked, bakes into
I
the
wonder
blob.
if you're almost doing something similar to what the new ECS sample is doing, where it's kind of baking those scriptable objects down into blob data.
Probably yes. All of these are scriptable objects. I add them, and then I go through this recursive thing. You can see here I get a type to scriptable object, so I only have one scriptable object per scriptable object type, and then I go through all of the scriptable objects that has this thing implemented. So I have a scriptable object, I make a version out of it, I implement this interface, and then on create here, I get the blob builder in, and where I'm supposed to put it in. This is that reference to the inner type that I need to fill in with the data. So in this one, it looks like this. this is, yeah, it's just tricky to explain in short form. I realize now when I look at it. Yes, if I had a yeah, um, but this is data that is inside of a scriptable object. This is straight up normal data, nothing more to it. You can see it underneath, I think. So a bunch of different data,
Oh,
bunch of
okay.
stuff. Wait a minute. Yes, yeah, exactly. Um, and I put that into my boomerang, and this is so this is the target that is declared in this contiguous space that I talked about. I put it in. I do some conversions here, and then I fill in all my blob assets or my all my curves. Uh, and you can see here how I have animation curves that I then put the speed curves pushed into a specific speed curve animation blob. So I'm like having a situation where I declare all the animation curves in the scriptable object, like normal animation curves, and then I bake them into animation curve blob and put them into this blob where I can access them like everywhere, like we just looked at. So there's a lot of curves everywhere, and all of them are done like this, where so this is the speed curve for the boomerang, which has a very specific movement pattern. Yeah, so I go all of these guys get recursively added. Like I call this create function on all of my scriptable object that has this interface implemented, and I recursively, or I don't know, recursively is not the right word, but I go through all of them and I let them put in their respective values into this blob asset root that I constructed, and then I just lock it in and I put it, and then the runtime goes off. So all of there's a million of these, as you can see here. General collision, good example. Here you have the physics category tags, the different tags of layers that the game uses, and in the create here, I set up a ton of different filters. You can take a look here. This is just a struct, and it just contains a bunch of collision filters for stuff that I regularly use: prop, player, enemy, environment, all filter. And this is the reference to that exact thing that we looked at, and I just put in a bunch of different versions of a filter into it.
Nice.
So
Just so you
then
can access those easily. That's smart. I like that.
yeah, you can see if we have this might be I can show one or two examples of how this looks in practice.
Yeah, because
uh,
then you don't have to build the collision filters from wherever you are in the code. You can just kind of grab those from your blob
yes,
asset.
so here we have another example, weapon settings. So here we have all the weapons. So this is very straightforward, like data like you normally would have in Unity. So far not something crazy. Also this is just straight up data. And then in the create here, uh, I I have like different parts of the data that I once again shove into this target. And remember, this was the target that just have all of the stuff. This is going to turn into the blob assets, right? So I just fill in all the data, some general data, throw extra angle, something I have a bunch of, and some more curves, and then I have one of these create functions for every weapon in the game. So we can take a look at the shotgun here, or we can see here we have once again data stored on a scriptable object, just nested into infinity. It feels like a bunch of curves, and I put them onto the shotgun. And then when I return out of this, I just create the blob asset from the root that I just filled in with all the stuff. Does that make sense? I
Yeah,
can walk all
absolutely.
the way out once, and we can just check out how it looks all the way
How
out here.
far deep nested you are.
Here should be the thing. Yeah, here we have it. Construct blob assets. all the assets, we create our blob builder, we create the root, and then this one, asset loader, create data blob, that just goes through all of the different scriptable objects, pushes all the data into this root, which will be the gameplay data inner, the one with all the stuff in. And then I lock it in, and blob ref is returned back, and it's put into, one is in the system data that is like a little bit more generalized, like it's only camera for some reason. I think that's a assembly definition reason. It's weird inclusion 3. And then we have the gameplay data that just creates the new component and just puts all of it inside of there.
Had you ever had any issues, like potential bottlenecks, like accessing data, because it is still technically like a random access, because it's not necessarily going to be stored with your entity data?
None at all. My thought around this was that I don't want to have copies of this for every instance of whatever object is using it.
Yeah.
That's it. Like,
yeah, the performance gains you get from doing that are far outweigh the potential performance hit you get from a few small random accesses here and there.
Yeah, exactly. So it looks like a lot, but I think when you just count it up, it's not that much. I think the curves might be the biggest thing here, but I've never concerned myself about if it's too much of a random access through that thing. Like, it's going to be random access somewhere, the other way solution anyway.
Right. Yeah.
So, but this way I was, especially since I have so many enemies, I have a lot of different stuff that has a lot of instances. And I just didn't want to have copies of all their constant data in all of them like that.
Yeah.
And then I felt like this should be able to do in one just single big blob. And there was a lot of syntax gymnastics, but eventually I got there.
Yeah, no, I like that, because you can kind of guarantee that your data is all going to be in one place. And again, there's kind of all the benefits of, you can access it in parallel, you can access it from anywhere without any additional dependency checking, and it's all good.
Yeah. And now when I think about it, so the final thing I should say here, about the serialization, if I'm not mistaken, this is in a baker, right? This is, baking in a subscene, which have like one single object that bakes in all of the constant data.
Right.
And puts it into this. And I think when I bake this and when I build it, it bakes it into a subscene, and the baking process understands that this blob asset should be saved as just binary data. And when it loads it, because the baking data, right, is part of the subscene. So all of the different, so by just baking this entity and then pushing all of this data into this blob asset that is contained inside of a component, you automatically sort of just push all of the data very cleanly inside of a continuous part of the memory into part of the memory, and you link that, and the Unity understand that, this component and this entity that I'm baking into the subscene, all of that blob data that's inside of that links to, we just push that also into the subscene, perfectly serialized, perfectly efficient. And then when you load this and you start the game in a build version, you don't do any baking. You just, obviously, you just load the binary data from disk, and it's just zero processing except for just taking the file and putting it into RAM, and that's it.
Right.
So I think all of this is just automatic with the serialization and deserialization, if I remember correctly.
Cool. I like it.
Yeah. I think that's the main gist of things. Yeah. Blob data.
Yeah, that's good stuff. And I just know I've done a couple of videos on some interesting things that I did with blob assets in the past, if people want to look those up on my channel. I know one of the kind of interesting things that I did was I created like a 2D grid, and I basically had all the cells be like elements of a big blob array. And of course, because it was a 2D grid, I had to save all the data in like a one-dimensional array. So I had to kind of, flatten the array so you can do like a little bit of math to determine, how to get to any given cell or whatever. And so what I actually ended up doing was creating a custom indexer. So, I'm sure many people are kind of familiar with an indexer where if you have like an array, you just kind of use the square brackets and say, oh, I want the, eighth element of the array. And you pass in the number 8 there. So you can actually create custom indexers in C Sharp. So I basically created a double indexer. So you could basically pass in the XY coordinates literally to the component that I'm storing my blob asset reference on. And then from that, it basically goes down into the blob array, finds the correct element based off of the 2D coordinates to 1D coordinates, and then returns that actual element from there. So that was just like kind of a cool little thing that I remember doing with blob assets. So yeah.
That's a good use of custom indexing. Very
Yeah,
much.
yeah.
Yeah. It's a
Not often
clean
you're going to
way.
need to create a custom indexer, but for something like that, it was super helpful.
Well, yeah, yeah. For people who haven't used that, you should try it out and don't
Yeah,
go
yeah.
ham on it.
Another
But
good thing to experiment with.
yeah, but you should use one of those features like once too much, and then you're like, settle in, like, okay, this is I get it now. Yeah,
Yeah,
that's
yeah,
the
yeah.
typical thing you do. You learn something, you're
Exactly.
like, oh, use it everywhere, and like, okay, calm down.
But then,
This
yeah,
is
put it away in your tool belt, and
yes,
use it when you need it.
yes. So good example.
Indeed, indeed. So yeah, with that, normally this is where we do kind of like a Q&A portion of the show. However, you will remember that we are not live here today, so unfortunately can't answer your questions live, although depending on timing of things, I may be hanging out in the chat or something like that.
Me
But if you
too.
do have any questions, yeah, feel free to drop them in the chat or the comment section of this video, and we'll be happy to either answer them live during the live chat or on the next episode or something like that. So yeah, we are already kind of over our pre-recorded allocated time. So real quickly, we can go through kind of like our dynamic allocations, just kind of fun things to share with the community here. I have your thing open if you want to go ahead and start chatting away about what you got here.
Yeah. So there's people probably heard about Teardown that came out like 2 years ago, maybe. Game where you can destroy things, and this is the developer. Shout out Swedish developers. He and if you ever need inspiration, or I guess also feel like a failure, so that I did when I read this the first time. You can go back to like 2017-18 when he started working on the tech that eventually became Teardown. So you're looking at that now, and that guy made the physics, the lighting, the rendering, all of it from scratch. There's zero Unity, zero Unreal, just custom everything here, and you can just follow. He doesn't tweet that much, but all of the tweets around 17, 18, 19, 20, 3-4 years there are just packed filled with like amazingly cool stuff that I'm like, oh, I dream about being able to create this from scratch in my life. Like I could probably do some of it, but the time and how fast and how high quality stuff he makes
Yeah.
just fascinates me to no end. So just scroll through his Twitter and just be amazed how much you can accomplish if you're just going at it and perfecting your craft for many years.
All right. And then, yeah, what I wanted to share, kind of also along the lines of graphics programming, the content creator Acerola. I don't know if you've came across this guy before. He has
I think I watched
awesome
every
content.
one of his videos.
Yeah. So yeah, he has a lot of really cool things. He was a graphics programmer at Sony Bend for a little bit, and yeah, he's very knowledgeable on graphics. His videos are also very entertaining as well. And yeah, he does a lot of good deep dives into how graphics work for different games, or even like kind of tutorials for setting up different types of lighting. This is one of my favorite videos by him, which is called "The Strange Graphics of Lethal Company."
Yeah.
So the game Lethal Company, if you see it, it's not really like all that like high definition looking of a game. Like this is basically a screenshot from the game right here. So yeah, pretty, low polygon count, very stylized. So one of the interesting things is this was actually created with Unity's HDRP, the high definition render pipeline. And this video goes through a bunch of different tricks they went through to achieve this kind of look. One of the interesting things is like the game is rendered at like a much smaller resolution, and it's not even actually a 16 by 9 aspect ratio. But then when it gets stretched out on a 16 by 9 screen, you kind of get this like pixelated look, and things look a little bit warped. So it's super interesting how they kind of came about this whole stylized look. So yeah, anyways, that is that. And then yeah, so we can go ahead and close out our show real quick here by thanking once again our Patreon and YouTube supporters. We really do appreciate your support. And also do just want to give a quick shout out to the supporters at the CPU register tier, which is our highest support tier. So thank you to eCool and Christian Luke for your support over there. I really do appreciate it. So anyways, with that, we can go ahead and wrap up episode 19 of the Hot Path Show. Hope you all enjoyed it today. And yeah, Tobias, you got any closing words for us here today?
No. Good stuff.
Good stuff. Good stuff indeed. All right, so yeah, thanks again, everybody, for hanging out here today, and we'll be back again next week. Hopefully, if the schedules line up, we'll be live once again. So, yeah, with that, take care, and we'll see you in the next one. See ya.